Okay, so a few other cutters here that you might see. There's some like this here. All right, so these are all milling cutters for certain specific processes. So I'll show you these first. So like these here are a dovetail cutter. Dovetails we see on our it's on our tool post, our Aloris tool post. It's on the manual lathe, and we quick change our tools, and it's that kind of shape, very similar to. Get an example part. Okay, so on this part here, I have a dovetail cut. So it's undercut like that, and basically the tool, and this one's too big for that, but that tool went inside of there and it recessed and did that undercut for you. So it's for clamping two parts together, very accurate, very good surface contact for grabbing onto something very effectively. They honestly use dovetails a lot, like when you get into really high performance milling and like 5-axis milling, when you want to work hold something down, they'll create a dovetail on the bottom of the part, and then you'll have a clamp that you'll actually slide the part into and then clamp it down. It's a very secure way to hold on to something. So anyways, special cutter, they come at different angles to create whatever shape you want inside of there, and that's just kind of creating that undercut. Before you can use a dovetail, though, you can't just go and use this dovetail cutter to create the dovetail. You're going to originally go through, and you're going to use like an end mill or something first to slot this out. You sort of rough out all the material, then you come through the dovetail cutter, and you basically just use this to create the undercut. So, similar to the dovetail cutter is the T-slot cutter. So the T-slot cutter is meant to cut like the T-slots like we see in the milling table, to hold down where your hold down nuts go to hold your vise onto the table itself. So this thing here is a cutting edge on this side, and then the next one is opposed and it's on the opposite side. So they go back and forth like that, and that's because it's meant to be able to cut in different depths. So you can go and cut on the base of it, or you can move up a little bit and then cut on the top of it. Again, before you can use this cutter to create a T-slot, you're going to have to go through with an end mill first and create that rough shape, and then it's very similar to the dovetail cutter. You're just going to go through and do that undercut specifically, but it can cut on both sides of this, and that's why they have them staggered like that. Another one that looks very similar to these is this one here, which is a keyway cutter. This is meant to cut like in a shaft. Let's just give you an example. We'll just say like the shaft of this here. If we wanted to go and cut a keyway into this, we would use this vertically and hold the part horizontal, and we would plunge in, and it's going to kind of create a radiused cavity inside of there, and that's where you would use like a Woodruff key, which looks like that, and that would go into your shaft, and that's what will create your key that sticks out. So that's another option, another tool you could use. And again, there you just keep going, odder and odder tools. So another one I have here. This one here is for a horizontal mill, but that's meant to cut a radius on the outside of something. So it's a formed radius. So this is at a specific size, maybe of 1/4 of an inch. And when you run it along the edge of your part, it's going to create that shape, that 1/4 inch radius on the outside of your part. So it'll cut this whole edge over and put a nice radius on there. And then there's the other version here for like the vertical mill. These basically look like a router bit, but what it is, again, is there's a radius right there. And again, you just go in, just like you would on wood or something, you would just run that along the edge there, and that's going to create that radius shape on your finished part there. So, what else do I have left here? Here's an odd one we haven't talked about yet. So this tool here looks like an end mill, but it's not. This is specifically for cutting threads, so it's a thread mill. So if you wanted to cut, external or internal threads, you can use this tool and you program it, and this would be done in CNC, and you'd have to tell X, Y, and Z to move down together, and this will slowly mill around there, and it'll actually create your thread pattern in your shaft. These are spendy tools. Just for reference here, like one of these things here, like this is only, 5/16 in diameter. That thing will cost you about $300. They're ridiculously expensive just because of all the special grinding that has to go into creating that shape on the end there. So, just I didn't even cover this, and I should have covered this right away, but just basic cutting tools to understand this. If you're looking at a cutting tool, the whole idea of any cutting tool that you're using is the tool needs to be a harder material than what you're cutting. So in this scenario, most of these tools like this are made out of a tool steel, and they're just a high carbon steel that's been heat treated, and then it's going to make this harder than maybe your material you're going to go cut, and that's how you can actually cut effectively with a cutting tool. Cutting tools need to be able to withstand cutting pressures, obviously. If you had something too weak and you go start milling with it, it's going to break that off, and that's not going to function. So you need a harder tool and a tool that's fairly stable, where it has some heel to it here so the teeth don't just chip off of it. And then it needs to be tough enough to resist shock, because when you're cutting, you're going to get shock, because as this is impacting, it's interrupted cut basically, and it's keep hitting each one of those teeth. So it needs to be able to handle all that. And then also it needs to be able to resist heat. If heat is going to, if the material doesn't have enough of the right elements in it, it can actually basically turn like glowing orange. And when it does that, that's because you're getting too much friction. If that happens in some materials, it will literally just melt down. Like somewhere, I don't think I have it with me here, but I have an example of like a drill bit that was bought from Harbor Freight, and literally the drill bit bent. Well, the whole reason of that happening is because it wasn't actually hardened and it wasn't made out of the right materials. So it was basically the same softness as the material. Normally when you have a drill bit or any one of these cutters, they are very brittle in nature, especially when you get to the carbide. If you're looking at solid carbide, this stuff is very, very fragile. Like if I just take this and drop it on the ground, there's a good chance it's going to chip one of those corners off and destroy it. So all cutting tools are very hard, and since they're hard and they have the right elements that are inside of it, it can handle those temperatures and it won't just melt down or smear the cutter. So otherwise, like the history of cutting tools, all cutting tools kind of started with, they actually started with carbon steel, which was just a hardened carbon steel. And then they eventually transformed into the high-speed steel, which is the tool steels that we use today. So, for example, all of these cutters that I'm looking at right here, these are all high-speed steel cutters. None of them are carbide. This one here is carbide, but all of these are made out of high-speed steel. And then they went through a transition where they said, all right, well, they learned about carbide, and they said, well, carbide's a better material to cut with. So they kind of did off with all of these, and then they went to stuff like this. And you'll see these every once in a while. On this cutter, we can look at it, and it's actually a steel body, but then it's a carbide insert, and these carbide pieces are brazed into there. Now that works really good because you can get the speeds of carbide, but you're still a cheaper cutter just using carbide for the teeth. And if you look at home, like if you have a skill saw or a table saw, chances are you have carbide teeth that are on your blade, and those are what's doing the cutting, and then it's just a lot cheaper to manufacture that versus going solid carbide. And the other benefit is the steel is a lot tougher than carbide is. Again, carbide's very fragile, so it might take some flex and things in this area and not be a problem. If it was all solid carbide, it could just shatter on you. So otherwise, so all of this brazed carbide that you see like this, and I can kind of show you a little closer there. You can kind of see the brazing. Maybe I've got a better one. This one's about the same. Well, these seats, they're brazed in place, and the problem with this here is that, having these locked in like that, you can't sharpen them. If you're going to sharpen these here, you have to go through and you're going to have a special wheel to sharpen it. So anytime you're trying to sharpen carbide, which is a carbide teeth on here, it is very difficult, and you have to have either a silicon carbide grinding wheel or a diamond wheel to actually be able to cut these. And a lot of times in your regular tool sharpening, you don't have those, so you're just going to be using like aluminum oxide as an abrasive that'll sharpen this. So this all of a sudden has to be sent out to sometimes a special shop to get sharpened, where if we go back to this type of insert where you have the insertable carbide, All right, well here the cutter is just worn out and you have to send it out and get fixed. Here, all you have to do is just flip that insert. And that's why Indexable Carbide's so popular, because it's so fast and user-friendly, and you don't have to worry about, oh, my cutter chipped, oh, big deal. Here you just flip a corner and now you're back in action. Here, you might wait for a week to get it sent out to somebody custom. So that's kind of the history of where all the different cutting tools came from. So just as a reference. Otherwise, I think I've showed you pretty much everything that's relevant here. Again, I talked about tools, and they are fragile. So you can see here, somebody here had done something with this cutter. I don't know, it was before my time, but there's a couple pieces of it. There's no distortion in this here. They had a serious problem of some sort, and they crashed this into something, I'm guessing. And this is just high-speed steel, but it just shatters like that. And it's so clean of a break, I mean, you can almost put it back together and not even tell that it was broken. That's how brittle materials will react when they break. A softer material is going to stretch and flex before it breaks, but we can see we don't really see any distortion in this, just because of how hard of a material it was. And then it just shatters. And that there probably cost somebody a day's worth of work and maybe a part that they were working on. So, all right, that is pretty much it. Oh, one more I didn't show you. Slitting saw. These here are very thin. A lot of times you will use these if you need to contour and cut something kind of right in half. You use something like this, and it's just like a saw blade. Basically, you're just going to go a lot slower than you would go with like a regular skill saw or something like that, and you're going to mill, and it's just going to cut with the periphery of these teeth here. But you'll see it for slitting parts. You'll see it for maybe sometimes putting a slot. Like if you wanted to put a slot in the end of a shaft, you could go through and just mill that slot in there with this. Otherwise, you can also just go through and, I don't know if I have a good example of one that's been cut in half. I do. Okay, so here was a part when it's been cut in half, and I guarantee they cut this in half with a slitting saw like this. You can get very accurate, and you can just get right in the middle of it, and you can see a cross section of everything. And that was literally just by, it was held vertically, and the part was held horizontally, and it just went through, and they just milled right through there like that. So anyways, that's where you do something like this. Fragile, again, these are pretty brittle as well. You gotta be careful with them because they can break very easily. All right, that is all for now. So now you've got a little intro to some milling cutters, and hopefully have a little better understanding of what's out there. And again, there's thousands of cutters out there. So this is just touching on the little box I have here to go as an overview. So thank you very much.